We're looking at graphs of functions in preparation for a lot of the work we will be doing when we get into calculus problems. So far, in the past videos, any examples we've done, we've usually asked questions. We're given a graph of a function, and we're asked questions such as, what's the value of x when the function equals 2? And we go to this point and we say, well, the value of x is 0. Or what's the value of x when the function is 6? And for that question, there are actually two different points on the graph of the function where the function is 6. So we actually have two answers, when x equals 2 or when x is minus 2. And we even asked the kinds of questions, what does f of 2 equal? F of 2 means you go to where x is 2 and you go find the value of the function. The value of the function is 6. So the key I'm making is, so far, everything we've looked at, the answers have been looking at specific points. But in calculus, oftentimes you'll be given the graph of a function, and the questions you ask, the answers won't be 1 or 2 or 3 points, but the answers will need to be in the form of an interval, because the answer is just not 1 or 2 points. The answer is a whole range of points, or a whole interval of points. In the last video, I sort of briefly touched on it, but now, of course, we will go into more depth to make sure this is understood. Let me do a very quick review of intervals. In the past, when you probably first learned about intervals, it was in the context of some inequalities. Just to make it very clear, we're going to go way back to when you first learned to solve equations. Here's an equation with one variable. And the goal was to find the solution, which means, I always describe it as, find the solution means find the value of x, that when you plug it into this equation, it works. You can also call that checking your solution, right? So this, the way we learn to solve this, is you add 2 to both sides, and then you want to get 2 by itself. So in this case, you divide both sides by 2, and x equals 1 is your solution, which means, does x equal 1 make this equation true? Well, you plug in x for 1, 2 times 1 is 2, 2 minus 2 is 0. And yes, that is the solution. Now, after you learned about solving these equations, and in this case, there's one solution. Maybe if you have some kind of quadratic equation where you have x squared, and maybe there's 2 solutions, but there aren't a whole bunch of solutions. There are 1 or 2 or maybe 3. It's according to what kind of equation you start with. But let's take this same expression, 2x minus 2, and now let's turn it into an inequality. So what we're saying here, when we are trying to solve this inequality, we are trying to find the values of x that make this inequality true. You know, if you plug in a certain number for x, is it going to be true? Now, when we end up solving this, the answer is not going to be just a single point or a single solution, but instead, once we solve this, we will see that x can be many different values, and we have to write our solution that includes all the possible values of x that are a solution for this. Now, hopefully you remember the way we solve inequalities is the same as we solve equations. We try and get x by itself. So I first add 2 to both sides, and then I divide both sides by 2, And here is my solution as an inequality. What this is saying is x is greater than 1. So any value of x, which is larger than 1, if I plug it in this inequality, it will be true. So for instance, let's just say, well, how about 2? 2 is greater than 1, so 2 should be a solution. If I plug in 2 into this inequality, 2 times 2 is 4. 4 minus 2 is 2. So is 2 greater than 0? Yes, it is. So in fact, x equals 2 is a solution. Let's say we try and check out x equals 0. Now from my answer, 0 should not be a solution. Let's plug it back in and see what happens. If I plug in 0 for x, 2 times 0 is 0, so 0 minus 2, you end up with minus 2, and we ask ourselves, is minus 2 greater than 0? No, it's not. So this is not a solution. So it looks like, with just looking at a few points, it looks like this looks to be the correct solution. So the solution here is written as an inequality. But the next step we learned was a lot of times we would take inequalities and we would graph these on a number line. And then from the number line, we would create the solution as an interval. So let's go through that, because that's going to be the basis of what we're going to be doing with intervals. So x greater than 1, so this is like the x-axis, it's like a number line. So say 0's here, and 1, and 2, and -1, and -2. So here's how, through the years, this has changed, but in the past few years, this is pretty consistent how people graph intervals. X greater than 1, you go to 1. To be greater than 1 means the numbers have to be larger than 1, which means all the numbers to the right. So I go to 1. Now the greater than, we always use parentheses to indicate greater than. And then what I like to do is I like to sort of draw a second line or another arrow and do this. This represents this in here is the solution. In other words, any value of x I choose over here should make this original inequality true. And also, any value I would choose over here to the left of my graph here, if I plugged in any of those numbers into my original inequality, it should not be true, because these are not solutions. So this number line is sort of another visual way to represent solutions. Now, what's interesting is eventually we can put numbers here, but you know what x actually finally goes to? If you go way far to the left, we call that going to minus infinity. And if we go way far to the right, then we call that x is approaching infinity. So the solution really is going to be any number larger than 1 and less than infinity. So solutions would be 2 and 3 and 5 and 10 and 100 and 1,000 and 1,000,000, right? All those are going to be solutions. Now what happens is, from number lines, the next and final step is we like to express a solution as an interval. So here, the solution is expressed as an inequality. This tells you what x has to be a solution. We go here, this is a second kind of way to express the solution in forms of a number line, sort of a graph. But the third way is an interval. And once again, the last class, the interval, and sometimes it can be confusing in math because it looks almost like an ordered pair. Why is that? Because you have 2 parentheses and then you got 2 numbers inside. It looks just like an ordered pair. And here's the case where in math, sometimes it's true, context is everything. If you're trying to solve a problem and you know your answer is going to be an interval, then when you write something here with parentheses, you know it's an interval, you know it's not a point on the graph. So even though these intervals look just like a point on the graph, obviously you know the difference. But an interval is a way to express this range of numbers here. And what you do is the first number is the smallest number in this whole range of solutions. And the second number is the largest. So if I want to express this solution as an interval, and the nice thing is, if you ever have or draw a number line and graph the answer, in some way, the interval sort of mimics or looks like the number line. Matter of fact, sometimes when I'm solving a problem, if I want to make sure I don't mess up and get confused, I oftentimes will quickly sketch out a number line. And then once I have the number line, I create my interval. So for instance, if I want to express this whole range of numbers as an interval, if I say, what's the smallest number in this interval? Well, it starts here at 1. So I put a 1 here. Now let me take a minute and explain another very important thing about intervals. There's two ways to express intervals. You can have parentheses or you can have brackets. When you have parentheses, that means you do not include the number here as part of your interval, part of your solution. Brackets mean that you do include the endpoints. And you can actually even have problems where sometimes one side is a bracket, you include one side, but you don't include the other side. I'll do some examples where we have brackets so we can see the difference. So this one, because look at my solution, x is greater than 1. The actual value of 1 is not a solution because x has to be larger or greater than 1. So that's why when I do my interval here and when I did my graph here, you'll see in a minute when I do a graph, sometimes I have to use brackets in the graph, and it's all based upon my inequality. So greater than 1 means I put a parenthesis at 1, which tells me I do not include the number 1 in my solution, but it's everything greater than 1. And then what's the largest value? If I think about this graph here, how far to the right does this go? Well, because it keeps on going forever, actually, the interval would be x is from 1 to infinity. 1, not including 1. A good way to say is the solution is x is greater than 1 to infinity. Let's do another problem. How about just for fun, how about so a couple things are different. The main thing at first glance is here I have less than or equal to. My first problem, I just had greater than. So now I'm going to solve this the same way. I want to get x by itself, so I'll subtract 8 from both sides. Now I did this problem because I wanted to remind you, in case you've forgotten, when you're trying to solve inequalities, there's a special rule that if you ever have to multiply or divide both sides by a negative number, you can do it. But remember, when you finish that operation. If you ever multiply or divide both sides of an inequality by a negative number, the way the math works is the inequality flips. So once I divide both sides to -4, I end up with x greater than or equal to -2. Now let's go ahead and do a graph for this. So once again, here's 0. I'll put -2 here. So I go to -2, and now because it's greater than or equal to, first of all, in my head, I know when I'm looking at greater than or equal to, that means numbers are going to be to the right, to the right are larger numbers. And here, since it's a greater than or equal to, I'm going to put a bracket, because brackets are what you use if you want to include the number, because my solution is going to include -2. So I go to -2. I know I'm going to go to the right. So I make my bracket like this. And then I go ahead and draw on my graph. So now over here are my solutions. I could have been up here. I could have called this solutions because there's a bunch of numbers. So my solutions are -2 and everything larger than -2. Of course, over here again, eventually, if you go far enough, you get to infinity. So if I want to write this solution as an interval, the smallest value of my interval is -2, and the largest value is infinity. Now let's do one more just for fun. How about I take this exact same problem, but only change one thing. Instead of less than or equal to 0, I'll put greater than or equal to 0. So I'm going to solve this inequality. Try and get x by itself. So subtract 8 from both sides. Divide both sides by -4, which flips the inequality. And then my solution for this is x less than or equal to 2. Once again, just because I like to do it, and I'm sure I won't make any mistakes, hopefully, when I do this. I'm going to go ahead and do the graph real quick. So here's 2. So x less than or equal to 2. Less than means the numbers have to be smaller than 2, which means my graph is going to start at 2, but then go to the left, because these are where the numbers get smaller. So since it's a less than or equal to, I go ahead and put the bracket here, but I'm going to head off to the left with my graph. Now, if I do my interval, so how far these numbers here, right? These are negative numbers, so they, the negative numbers, sometimes we say the negative numbers get bigger, like -10. In some ways you think, well, -10 is bigger than -1, although in reality, -10 is actually less than -1. I mean, the farther you go to the left, the numbers are actually getting smaller, even though it sort of looks like they're getting bigger because 10 looks bigger than 1. But that's not true if it's -10 and -1. -10 is smaller or less than -1. So if I head out to the left and I keep going, what do I eventually get to? Well, I'd eventually get to -infinity. That's important because when you write an interval, so here's my solutions are now this range or this region here. To write it as an interval, you always start with the smallest value. So the smallest value of this range of numbers is going to be -infinity. Now, what's interesting, well, let me go and finish and I'll say a few things. And what's the largest value? It's 2. And here I'm going to include 2 in my solution since it says x less than or equal to 2. So 2 is included as part of the solution. Now, someone might think, well, if you put a bracket here, why would you not put a bracket over here with negative infinity? Well, another one of these math rules is that, infinity, sort of in our way of thinking, means a very, 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 very large number. I mean, it is a number, but it's very, very large. So big, we can't even really imagine it. But you know what? In theory, you can never, ever, ever quite get to infinity. So that's why with intervals, anytime you have an infinity, you always stick a parenthesis with infinity, because the parenthesis means you don't really include this number. We can never quite get to infinity, so you put the parenthesis. Down here, with the negative infinity, because we never quite get to negative infinity, it's also a parenthesis. All right, so hopefully that's a review of what it means to give solutions as intervals. The whole idea is the solution is not just one or two numbers or one or two values of x. Instead, the solution is a whole range or region, or we could say a whole interval of values of x. All right, so now, based upon that, we can go look at some graphs of these functions, and based upon the kinds of questions we're asked, we can see that the answer is going to have to be in the form of an interval. Sometimes when they give you a question, they will actually say, give the answer as an interval. And hopefully they do most of the time. But really, when they ask you a question, according to the question, you should know whether the answer is going to be a point or an interval. So just to see the difference, I'm going to go back. This is a graph we've used before. Now, just so you know, especially whenever I make graphs like this, the little program I use, they don't put arrows on the end. But the assumption is, unless there's a big dot here, if there's a dot, that means the graph stops. So just so you know, if you remember, if I have a graph like this, and they have a big dot here, that means the graph actually goes from -2 to 2. The graph does not continue. But normally when people draw graphs, and sometimes even I will, maybe I'll forget to put the arrows on. If there's no dot there, then that just means actually the graph continues going on in this direction. When you look at these graphs that I generate on the computer, I may not in the future draw these arrows, but you can assume this just goes on. Really, it goes on to infinity, right? Or negative infinity. So just to get the contrast, let's ask a question that we asked previously. So for instance, I could say, where does, let me do it this way, where does the function equal 6? Hopefully you remember, function is the vertical axis, horizontal axis is x. So when they say, where does the function equal 6? I'm going to go up here on my function axis, going to go find 6. And then I think I look at, this whole line represents y equals 6. And I see that there are two places on my graph, on my function, where the function equals 6, here and here. So when it says, where does the function equal 6, the where is asking, what's the value of x? What's the value of x where the function equals 6? Well, here's this point, the x value is -2. And this one, the x value is 2. So the answer is there are two values of, there are two values of x that give this solution. Where does the function equal 6? When x is -2 or when x is 2. However, what if I said instead, where is the function less than 6? So what is that asking? It's saying, okay, here's this graph, this line represents the function. And they're saying, where's the function less than 6? If I wanted to be even more clear, I could have said, for what values of x is the function less than 6? Same question. This one is a little clearer because it sort of clues you in on the solution is going to be the values of x. So let's look at the principle of this. If I look at this function, it's asking me where is this function less than 6? So over here, like right here, it's around 10. Here, it's like 8. Here, at this point here, the function is actually 6. As I keep going, because it's going down, from this point on, all of a sudden now my function is actually less than 6. So matter of fact, it gets down here to 2. And I keep going, the function begins to increase, but it's still less than 6. Like if I stopped here, it's at 4. Here, maybe it's a 5. But finally, when I get to here, the function is 6, and then it keeps increasing. So in a sense, when I say for what values of x is a function less than 6, it sort of starts here and goes to here. This is the portion of the graph of the function where it's less than 6. Now, what are the values of x? Well, in a sense, all these points are a solution because every one of these points on this graph, the function is less than 6. So when does that occur? It occurs when x is larger than 2. So when x is -2, my function is less than 6, and it stays less than 6 until x gets larger than 2. So between -2 and 2 on the x-axis, my function is less than 6. So the answer has to be an interval, and I have to include all these values of x for this whole portion of the graph. So the answer is x equals, so the interval, since I'm saying less than, I don't include this point. So it starts at -2. -2 is the smallest value of x for my solution here, and it goes all the way up to 2. So the solution or answer to this question for what values of x is the function less than 6, it's -2 to 2. Just for fun, another way to ask this question, if they really want to make it simple, they could say, where is f of x less than 6? That's the very most precise way to sort of answer that question. Sorry, my phone keeps going off. Let me silence it for now. So if I were to make it super compact, super simple question, instead of all this wording, which is sometimes helpful when you're first doing this stuff, but at some point they may just throw this at you. Where is f of x less than 6? This real simple question, they're basically saying, what are the values of x where the function is less than 6? And because there's going to be multiple answers, it's going to be in an interval. Now, sometimes when they ask this question, That's it. Sometimes they'll say, give the answer as an interval. Now, really, you should get to the point where they don't really need to tell you this, because if you understand what they're asking here, you realize the solution is all these values of x right here. So it really has to be written as an interval. But sometimes they're sort of nice and they sort of give you a heads up, like, oh, by the way, this answer is an interval. Just for fun, let's do this. Where is f of x greater than or equal to 6? So first you look at what they're asking you, and then you go to the graph. And what you really do is you want to find, we're looking for, this is actually asking for a solution. Like, what are the values of x that cause this function to be greater than or equal to 6? So once you understand what they're asking you, it's almost like you go to the graph. Sometimes what I will do, I will find the parts of the graph that are the solution to this question, and I'll sort of circle them. And then once I circle, maybe there's only one part of the graph. Sometimes there's like two parts of the graph. Sometimes if it's complicated, even three parts of the graph that are a solution to this question. So this question, they're asking, okay, let's go look, let's figure out where in this function, where in this graph is a function greater than or equal to 6. So once again, 6 is right here. We keep using this example. So now I want to know where in the graph is the function greater than 6. So if you think about your graph, when I start up here, what is my function up here? My function's like, it's like bigger than 20. Here it's 20. That's 18, 16, 12, 10, 8, 6, boom. When I get to this point here, all of a sudden my function is equal to 6. And as I keep going, then all of a sudden my function is actually less than 6. So as I trace out the graph from the left here, it's almost like this part of the graph is going to be my solution, because this part of the graph is when the function is greater than 6. This part of the graph, this part of the function is less than 6. So that's not what I'm looking for. But eventually I get to here and the function gets back to 6. As he keep going, all of a sudden the function is now once again larger than 6. And that's what they're asking me. Where is the function greater than or equal to 6? So then I realize there's actually two parts of this graph that answer the question. And then you got this gap in the middle. In the middle here, the function's less than 6. So this is not the solution. So I need to write, what I'm going to do is write the interval for this part of the graph. And then also for this part of the graph. It's like my answer is going to be 2 intervals. Because I have this gap in between, I have to write these intervals separately. So there's a couple ways to do that. Either way is going to be okay. So if I look at this first interval, so once again, interval is the smallest value of x to the largest value of x. Of course, smallest value of x, this thing goes to negative infinity. And then for this interval right here, it goes to this point, which is -2. Now we have to ask ourselves, what is the question? Here it says, where is f of x greater than or equal to 6? That means you want to include the point in your answer, since it says greater than or equal to. So in this case, I'm going to put a bracket at the -2. Now you can do two things. Sometimes when you first learn these kinds of problems, you had this thing called a union. and you have a union sign which says the solution is this interval and a second interval. So that's one way to do it. So I'm going to take this first interval and union it with my other interval. So if I want to write the values of x for this part of the graph, well, x, smallest value in this interval, x starts at 2. Whoops, but it includes this point because it's greater than or equal to. So I put a bracket and it starts at 2. And then how far does this go? Well, once again, goes to infinity. So where is f of x greater or equal to 6? Well, x, the interval from -2 to negative infinity to -2, which is this part of the graph here, and then from 2 to infinity, this part here. Now, sometimes you may see the answer like this, and it's okay also. They just sort of, instead of putting the union sign, they just have a comma because they're saying basically, you know, it's both of these intervals. Either one, I think a lot of times is okay. Let's do a couple more just for good practice since we got this graph up here. How about I say, where is f of x less than 0? So the question is, where is f of x less than 0? So I'm going to go to my graph. What I'm looking for is what part of the graph, where's the function less than 0? Once again, the function is my vertical axis. You know, down here is where the function is 0. So 0, 2, 4, 6, 8, 10. So I look at my graph. It looks like my graph decreases and my function decreases. And then it gets to here, which is like 2. It gets down to 2. But as I keep going to the right, it starts to increase again. I'm wanting to know, where is the function less than 0? I want to know the part of this graph that's less than 0. And you know what? I realize there's no part of this graph. This function is never less than 0. It's always above 0. So this would be one of those 0 with a slash through it means no solution. There's no place in this function that's less than 0. What happens if we did this? Where is f of x greater than 0? So what do you think? I'll let you take 5 seconds and think what the answer might be. Where is the function greater than 0? Or we could say, what are the values of x where the function is greater than 0? Well, if you think about it, so up here, when I start out with this function, it's greater than 0 because this starts out like a 24, it goes down to 20, goes to 10, goes here to 2. All of this is greater than 0, matter of fact, and then you get past x equals 0 and it starts going up again. So you know what happens? Actually, this whole function, this whole graph, the function is greater than 0. No part of this graph or function is at less than 0. So as an interval, what do you think you should do? Well, how far out to the left do I go? Minus infinity. How far to the right would this graph go? What's the value of x as far as I can go? It's infinity. That's your solution. Sometimes when you have a solution like that, instead of an interval, they'll just say all real numbers. and there's a special math symbol for all real numbers. It's like a double vertical line turned into an R. That little math symbol stands for all real numbers. All right, what if we say, maybe do one more. Where is f of x greater than 2? So here's it. So we're looking at where's the function greater than 2. So let's go back and look at the function. Where is the function greater than 2? Well, here it's greater than 2, greater than 2, greater than 2, greater than 2, greater. You finally get to here at this very sort of bottom of this little u here, the function actually equals 2, and then it starts getting larger again. So your first answer might be like, wow, the whole function, the whole graph is greater than 2. But is that really true? What actually happens at this one point, at this lowest point? Later on, we'll call this the minimum point. This is the minimum point of the graph. When x is 0, the function is 2. But what's my question saying? They want to know the values of x where the function is greater than 2. So what's interesting is my function, the whole function is going to be greater than 2 until I get to that one point. And there's actually one point here where the function is not greater than 2. And that's because at this point here, the function actually equals 2. So we cannot include this point. We cannot include the point where x equals 0, because when x is 0, that point equals 2. When x is 0, the function is not greater than 2. It actually equals 2. So it's almost like we have two regions. It goes all the way to 0 and stops, and then it picks up again. It starts at 0. It's almost like of this whole function, there's only one point that is not a solution. And that's here at when x is 0. So what would the answer be? It's got to be two intervals, negative infinity to 0, and then from 0 to infinity. In a sense, what I've written here is I'm just skipping, I'm skipping one value of x. When x is 0, that is not a solution to this question. Last one for this graph. Oh, it should be where is, sorry. Where is almost the same, but only one change. Where is f of x greater than or equal to 2? Previous question, where is f of x greater than 2? And then we had this little issue here. Once we got to our lowest point of our graph, when x was 0, the function equal 2, so we could not include it. But now the question is, where is the function greater than or equal to 2? So what happens when I get down to my smallest point? Is it a solution? Well, yes, it is, because this is saying, give me all the values of x where the function is greater than or equal to 2. So for this part of the graph, this is the greater than 2. The function is greater than 2. I get down to here, the function equals 2. But for this current question, that's still part of the solution, because they're asking where is the function greater than or equal to 2. So I include this. And then, of course, when I keep heading to the right, the function gets larger. So what do you think the interval for this would be? All values of x. This whole graph here the function, this whole function is greater than or equal to 2. Or once again, you could have said, if you wanted to, all real numbers. All right, let's stop this video. I want to do a few more examples of this kind of thing just to make sure you've got it down, because this is really one of the key ways that we have to solve calculus problems. A lot of times the answers in calculus are intervals of x, but not just single points. So let's do a few more just to make sure you've got it down. But we'll start with the next video.